everyone, let's talk in this video geometric progressions. What is a geometric progression? Let's try to look at the example in this book. 3, 6, 12, 24, and so forth and so on. As you notice, for you to be able to get the 6, you need to multiply 3 by 2. Then 6 by 2, 12 by 2. This is therefore 24 by 2 is 48. Then 48 by 2 is equal to 96. Alright? Now, this is what we call a geometric progression because to get the next term, we are multiplying by a common ratio. Common ratio. Okay? Now, let's try to rewrite this ratio as 3. Then the 6 can be written as 3 times 2. Right? 2 is the common ratio. The 12, the third term, can be written as 3 times 2 squared. The 24 can be written as 3 times 2 cubed. And let's keep on writing until 48. That is now equal to 3 times 2 to the 4. Okay? So what do you notice from here? If, let's say, let 3 be equal to A, and let 2 be equal to R. So we can get a generalized version, a generalization that this is an A. The next term, the second term, is A times R. The third term, okay, A times R squared. The fourth term is AR cubed. The fifth term is AR to the fourth. Okay? So this is the first term, the second term, the third term, the fourth term, the fifth term. Please take a look that that the number of terms or the position of the term is just 1 minus the power. Look at that. 4 minus 1 is 3. 3 minus 1 is 2. 5 minus this is 4. Therefore, having said that one, if, for example, you are on the nth, okay, the nth term, what will be the nth term? So basically, it begins with A, followed by R. Then what will be the power? As what we have seen here, 5, 4, it's always minus 1, 4, 3. So if this is n, so therefore this will be n minus 1. And this one, guys, is your last term. Take a look. That is the last term of the geometric progression. Okay? So, the one that I would like you to remember here is this. Let's say you have a geometric progression and you are looking for u sub 4. U sub 4 meaning the fourth term. So therefore, the fourth term will be equal to AR cubed. Please take a look, AR cubed. This is 3 if this is 4. Okay, if you are looking, for example, for the u sub 20, the 20th term, so what would this be? AR to 19, because it's always one less than the position. Okay, don't forget that. 20th term is A to the 19. Alright? Now, how do you get, for example, you know the first term, second, third, and fourth, and so forth and so on. Let's go back to this. Let's go back to my example here. How can we get the ratio as equal to 2 in this example. Do you notice that that is 6 over 3? That's equal to 12 over 6. That's equal to 24 over 12. Okay? So, meaning to say, for you to be able, this is the value of your R. What does it mean? You need to take the quotient of the succeeding, the next two terms, okay, for you to be able to get the common ratio. All right? So in general, if your first term, okay, we said our u sub 1 is a, our u sub 2 is ar, our u sub 3 is ar squared, our u sub 4 is ar cubed. For you to be able to get the ratio, that is equal to u2 over u1, okay, which is basically ar over a. See, you can cancel the a. And that r is also equal to u3 over u2. Look at that, which is ar squared over, okay, ar. When you cancel this, that will also be your r. Okay, so please take a look of this one. So again, before we proceed to the example, the things that you need to remember is that in geometric progression, there is a common ratio. All right, there is a common ratio in geometric progression. Okay, and then the last term, or u sub n, is equal to a r to the n minus 1. And for you to be able to get the r, that r is equal to the ratio or the quotient of either the second over the first, or the third over the second, or the fourth over the third. It's up to you. Okay? And another thing that you need to remember is that if you are looking, for example, for u sub 15, that is equal to a times r to the 14. Okay? So the 15th term is for ar to the 14. The nth term is ar to the n minus 1. Okay, this is the nth term. Nth term, u sub n. Alright, let's try to look at this example here. The question says, the third term of geometric progression is 9. Again, in your head, third term. So meaning that is a r squared is equal to 9. And the common ratio is negative 3. You know the common ratio. Find the sixth term and the nth term. Again, how shall we get the sixth term? You know the r, therefore we need the a. Why? Because the u sub 6 is a r to the power of 5. You know the r, we don't know the a, then we need to find that a. How can we find that a? There is only one variable, and that is a, so therefore we only need one equation, and that equation can be taken from here. Alright, so it says a r squared, so that is negative 3 squared is equal to 9. Alright, therefore a times 9 equals 9, so therefore a is equal to 1. So the first term is equal to 1. If the first term is equal to 1, so the u sub 6 now is equal to ar to 5. So that is equal to 1 times negative 3 raised to the power of 5, which is equal to negative 243. What is now the u sub n? Again, the u sub n is equal to the first term r to the n minus 1, right? So the u sub n is equal to 1 times your r is negative 3 raised to the power of n minus 1. So therefore, the final answer of u sub n is equal to negative 3n minus 1. Alright? Let's try to discuss the example number 10. The nth term of geometric progression. It means nth term. So what is that? That is u sub n. And it says equal to this. 10 times 1/2 raised to n minus 1. Find the first term and the common ratio. Alright? So, for you to be able to get the first term, that is n is equal to 1. Correct? So, if n is equal to 1, so this will be u sub 1 is equal to 10 times 1/2 raised to 1 minus 1. That's from here, which is 1/2 to the 0. 10 times 1/2 to the 0, which is equal to your 10. Okay? So that is now the answer to that. Now you are looking for the common ratio. Again, what did we say? For us to be able to get the common ratio, we need to get the second term over the first term. We don't know the second term yet, so let's try to find the second term. U sub 2 is equal to 10 times 1/2. Okay, 2 minus 1. So therefore, 10 times 1/2 is equal to 5. So therefore, the common ratio now is equal to the second term all over the first term, which is equal to 10. So therefore, the common ratio is equal to 1 over 2. Alright? Actually, the common ratio, even if you don't find the second term and the first term, if you know the position, you would be able to infer that this is actually your r. Okay? Even without finding the second term. Alright? So I think we're gonna end here for a while for this video. The next one is we're going to discuss the sum of geometric progression.